culmination of this sequence, 1400 volunteer cast, paying tribute to this man really, because he's the one who changed the way we all communicate today. So Tim Berners-Lee, the British scientist who invented is for everyone, his famous gift to the world, and Danny Boyle was determined to give Tim Berners-Lee a very prominent place tonight.
It really is like the soundtrack to many of our lives.
Ladies and gentlemen, the inventor of the World Wide Web, Sir Tim Berners-Lee.
We completed a previous video with the heady success of viewing our first web page. Admittedly, it was only the default server test page that displays the server is installed, but it proved that everything was working. Here we discover how to modify that initial page and learn some HTML, hypertext markup language, the basic language of the web. Now it is possible to view web pages in text mode, but it's pretty dull. So here we use our Windows or graphical Pi machines to test our code. This is how. Recalling our previous setup, we had a Windows machine, a Pi in graphics mode, and a Pi in text mode. Apache was the name of the web server that we installed on the text-based Pi. We use clients called browsers to talk to the server and view its websites. There are plenty of browsers around to choose from, just take a pick. They're all free and the popularity can be seen here. There appear to be 3 browsers on the basic Pi system at the moment: the Midori, NetSurf and Dillo. Give each a try. Some may be a little limited in their capabilities, as we will see later in the JavaScript videos, but hey ho. It is possible to run both the client browser and Apache server on the same machine, and if you only have one, you're forced to do so. You can even run a text window and edit your HTML code at the same time. You can slow down this demo video should you wish to see this being achieved. It's always a little more impressive if the client and server run on separate machines, particularly as you can have many clients looking at the server at the same time. So how is this set up? In the text window, enter ifconfig to find the IP address of the text machine, the server. Enter this address into the address bar of the browsers. You will see this first page. If you have a single Pi, open 2 windows, one browser and one text window. On a Windows machine, open a browser and use PuTTY to connect to the text Pi. All of this has been covered in a previous video. Entering Nano. However you get to a text screen, log in as root. And after you've entered your password, enter the command mv/ect nanorc/nanord. This simply removes the colour coding so that you can read the screen. If at a later date you wish to bring the colour back, just reverse the command. Now change directory. cd/var/www. ls-la. The only file visible should be what is known as the default file. It's called index.html. In Windows machine, this file is actually called default.htm. You may recall from previous videos that we can see what's inside this file by typing cat index.html, all in lowercase as shown in the directory listing. There you see the HTML file that produced the initial screen. What we want to do is to edit this file, so we use the small editor called Nano. Enter nano index.html. We are now inside the program Nano. It's a small but very capable editor, and we will use it a great deal on this course. You can see the contents of index.html here, and across the base of the screen a list of some of the instructions available. Use the arrow keys to move around the text, or select one of the commands from the area at the base of the screen. You can use any Nano command. The ones shown are simply the most popular ones in this particular context. The little caret sign means control, i.e. you have to hold down the control key whilst pressing the character. If you simply want to exit Nano, press Ctrl X. you'll come out directly to the prompt if you have not made any changes. If Nano detects that you have changed the text in some way, it will ask you to save modified buffer, Y or N. To forget and destroy any changes, just press N for no. If you want to keep changes, press Y. The instruction bar then changes to read File Name to Write. The default is the name of the file you just opened, here index.html. You can hit Enter to accept or rename to save a file by another name. If you've made a mistake at any point, just hit Ctrl+C and your action is cancelled. The only other command you may need at this stage is Ctrl+O. This allows you to save at any point, again with the option to change the file name. So if you've been following this, just press Ctrl+C to cancel and the command Ctrl+X to end. And if necessary, N to say no to saving any changes. Writing our first HTML page. We can call our first HTML page anything we like, so long as it has the extensions HTM or HTML. So using Nano, we can start our first page by typing nano space first.html. Nano opens again, but this time with a blank screen, as we've yet to write anything. In fact, Nano confirms this by presenting New File here. The first thing to know about HTML is it is very forgiving. It will make every effort to display something despite errors we may make in typing. The second thing is that it is case insensitive. It does not matter whether we use capitals or not. But if you've been following this course to date, you will have noticed that our advice is always use lowercase. The third thing is that this is a markup language. It uses what is known as tags to mark important passages. In HTML, tags, like buses, generally tend to come in pairs. There are, of course, always exceptions, and these will be pointed out as they occur. So let's see. Just enter this text. Here is a very long line. It runs across the full width of the page without a break. Here I would add 3 spaces between every letter, and this is a new line on its own. Press Ctrl+O, up comes file name to write, first.html. Accept this by pressing Enter. Now go to your browser and enter http:// the IP address of your server /first.html, all in lowercase as advised. If all is well, you should see the page, but is it what you'd expected? Compare what is displayed in the browser with what has been written. And now watch this. Watch what happens as the browser is reduced and expanded in size. The words wrap to fit the screen. What is going on? In brief, this displays several things. The first being that we can just type plain English or any language the machine is set up for, and the server and browser will display it. The second is that the browsers wrap the text to fit the size of the screen, but it does not recognize new lines, and it also ignores multiple spaces. The word 3 here was spaced out with 3 spaces between each letter. The browser has just reduced this to 1. Although unusual, this is all entirely normal, and we will see why later. Tags. Remember what was said about tags. Tags usually come in pairs, an opening tag and a closing tag. The tags surround what is known as the HTML element. Beware of the potential exam question. The element is between the tags. The only difference is that the closing tag has a bar in it. So let's put HTML tags into our first page and see what happens. At the start, enter HTML, the opening HTML tag, and at the end, let's place the closing HTML tag. Notice the bar, which if you've been used to using logical notation stands for not. So we have marked up this page as starting HTML, and anything afterwards is not HTML. We have already seen that the browser does not care about lines or spaces, so we can move all of this text around as we please. It will not matter. Now every HTML page should have a head and a body. So let's put these in. Notice that they also go in as pairs. Here is the head and the head bar, and the body bar. Now, as the text has to be in the body, we will put the body bar down here. So we have the head, head bar, body, body bar, all inside the HTML and HTML bar tags. Tags can be placed inside one another. This is known as nesting, and another likely source of exam questioning. Let's try one more element, title. The title is nested inside the head tags, so title and title bar. And inside the pair of tags, let's write, "This is my first page," and then press Ctrl-0 to save. Rebrowse. Go back to the browser. Nothing has changed. Why should it? How does the browser know anything has changed? It can't keep requesting data, which will be a waste of bandwidth. We need to tell the browser to go back again and look at the modified first page.html. Some people use reload, but this will not always work and causes problems. The certain way of forcing the browser to reread our first page is to hold down the Control key and then press the F5 key in the top row of keys on the keyboard. It may appear that nothing's happened. Well, you've not changed the text in any way apart from up here. The element entered into the title tag has appeared up here in the title of the window. Our basic loop. Now this circuit of operation is going to become familiar. Editing details in Nano, saving the changes by pressing Ctrl-O, moving to the browser and clicking Ctrl-F5 to see the results. There were a number of questions on the first release of this video from viewers asking why not just use the reload function, common in browsers. It's a valid question. In an attempt to speed up your viewing experiences, the browser will keep a copy of items you view. If you go back to review, the browser can use this copy held in what is known as its cache. And this saves the time and bandwidth of going right back to the server and asking for the same details again. Using the Ctrl-F5 option forces the browser to ignore the copy in the cache and download a fresh new copy. Now you have your own method of learning and testing any HTML. It could be referred to as your personal learning platform. You can stop here and use it in any of the dozens of courses available on HTML. Here, I'll continue with HTML, and in the end I'll show you how to connect your Pi to the web so that your pages can be seen from anywhere in the world. Going back to Nano, you can enter 5 basic tags to confirm how they work. Let's put a pair of B tags around these words, I tags around these, and U around these. Now let's put P tags here and here, here and here. And finally, and this is unusual, let's place one BR tag here and another single HR here. Press Ctrl-O and go back to the browser and press Ctrl-F5. Now things have changed. Compare the text in the browser with your code. The B tag causes the text to become bold, and the I tag produces italic font style, and the U causes an underline. Notice that the P flags have forced the text into blocks or paragraphs, and the BR flag has caused a single line break, and finally put in that new line for us. HR produces a horizontal rule that stretches right across the complete page. Review. In this section, we generated our first web page. Nano wrote a file called first.html on the server in the directory /var/www. Nowhere else will do. The file name was all in lowercase and had to have the file extension HTML or HTML to be seen as a web page. A browser ignores new lines and more than one space typed in at a time. Web pages include tags that normally come in pairs. Tags look like this and have an expression in the middle. Tags can also be nested. Some tags, called unitary tags, do not form pairs, i.e. BR and HR. Pressing Ctrl and F5 forces the lazy browser to reread the page. Hyperlinks. Go back to Nano and enter a pair of A tags around the letters BBC. The A tags require a little more information to operate correctly. This additional information is called an attribute, and in this example we will link to the BBC's website. You may have entered it yourself into the address bar in the browser. This is how to get HTML to do it for you. Inside the first A tag, carefully enter the attribute href equals speech marks http://www.bbc.co.uk. Speech marks. I say carefully as it is always the one that causes the highest number of errors in any training. Something is always forgotten or mistyped. Save and view in the browser. Move the cursor over the word BBC and notice that it changes its form. Left click. Now the power of our simple reference in our little text file becomes apparent. This is the hyperlink. This trivial collection of letters has caused your page to be linked out across the internet via the web to another page on another server. Now that server is unlikely to be a Raspberry Pi. Connecting files across different machines is what the web is all about. Let's now return to Nano to link two of our own pages. Type in, this is a link to my second page. We want the word second page to point to another web page we will call second.html that we've yet to write. So, place A tags around the word second page. Now add the code that points to second.html. href equals speech marks second.html. Close speech marks. Press Ctrl O to save first.html. Let's now modify first.html to produce second.html. So, up to the title and change first to second. Change the reference here to point back to first.html and the word here to point to first. Now press Ctrl O, but change the name of the file you are saving here in the instruction bar to second.html and press enter. Nano helpfully double checks that you want to save the file under a different name, so type Y. Then type Ctrl X and ls space -la. You should see the three files in /var www. First.html, index.html and second.html. They're all in alphabetical order. If all is well, first.html will contain a link to second.html and second.html will contain a link to first.html. Go back to the browser and press the back button. Click F5 to reload the page and there is the link to the second page. If all works well, you can jump back and forth between these two web pages. These links take us back to the absolute and relative addressing mentioned in previous videos. The link to the BBC is an absolute link. The term for the link is URL, a Uniform Resource Locator. It is what you type into your browser, http://www.bbc.co.uk. Note, HTTP stands for the Hypertext Transport Protocol, mentioned before. The acronyms are now going to be coming thick and fast. By contrast, the links in our two pages are relative links, as these two files sit inside our web server. Recalling file structures from before, we know that first.html and second.html are actually sitting in /var/www/first.html and /var/www/second.html. But the outside world doesn't need to know this. /var/www is therefore known as the root of our Apache server. One thing all browsers do is provide you with a copy of the HTML they see, and allows you to see the code the web page author used to produce the web page. This is an excellent way of learning new code. In Firefox, here, Tools, Web Developer, Page Source. It will reveal the code received by the browser, all nicely line numbered. Don't be too demoralised by inspecting the BBC source. It looks more complex than it really is. A few more examples here, and you'll be dashing off this stuff in your sleep. and earning a fortune in the process. Meanwhile, back to reality. There is just one more aspect of hypertext linking that needs to be covered so that you can confidently claim you know everything there is to know about hypertexting. We have covered external links to the BBC and local links between your two local files. But if you have a very long document, you can jump to the exact paragraph or word inside that document. This process uses the same A tag as before and is known as an anchor. Return to Nano and open first.html. Anywhere in the text enter this link, a direct link to chapter 2 of this document. And save, and now review in the browser, Ctrl F5. The page should not only jump to the correct document, but also jump down to chapter 2. Using the source page view, see how awfully bad formatting code can look. To get this link to work above, all that needs to happen is to add the tag aname equals number 2 into the code. This completes all you should ever need to know about hypertext links. Take a further look at the HTML_example code. It has been entered to look dreadful. In the next section, we'll be looking at inserting tables and images. The reason for selecting tables and images is that table checks you understand nesting tags, and images are used to check an understanding of attributes and file structures. Tables use so many nested tags that if you can build a table, you're likely to have everything else covered. Sorry. That is sufficient nesting for the moment. For more examples, see the HTML_example downloaded. Note: tables should only really be used for presenting tabulated data. They should not be used for presentation. Images. ls-la shows us the 3 HTML files on your server. We're now going to add a picture, or image as HTML refers to it. In an earlier video, we learned that placing everything in one directory soon becomes unmanageable, and so it is with our web server. So we're going to make a separate subdirectory called images. So, make dir images, and change that directory. cd images, pwd to check we're there, /var/www/images. Fine. Now we need some images. To speed things up, we can use the wget facility we used before. So type. If all goes well, the image of satim.png is downloaded. cd ... Go back to the var www directory and open first.html. Insert this code. Image src equals /images/satim.png alt an image of Tim Berners-Lee. There are several lessons to be learnt from this entry. Images have to be either GIFs, JPEGs or PNGs to work on the web. Other formats are not supported. They have to be referenced correctly. Note here the /images that refers to the images as being inside the image subdirectory. And capitalization matters. When referring to the image, the S and the T have to be in capitals, as Raspbian is case sensitive. Always include the alt attribute. This should describe your image. Your design will not pass inspection without this accessibility enhancement. It will also help you go up the ratings in search engines. Go to the browser and view the page. The image is very large. We can control the size of the image using an attribute like this. If you only need a small image, reprocess it in your graphics program. Make it smaller. This will speed up the download of your page. As an example of more nesting, you can make an image into a hypertext link, like so. Give pictures a meaningful name. It will help search engines reference your site. Lists. There are 3 standard lists: unordered lists, ordered lists, and definition lists. Examples exist in the examples page. Forms. The HTML form is the input element. It consists of text fields, password fields, radio buttons, checkboxes, and submit buttons. Now these are mentioned here for completeness only, but are covered completely in a later video on PHP, where they can be used far more effectively. What do all these pages have in common? All appear to be individual and have a different look and feel. Closer observation reveals that all the text and links are exactly the same. They all share exactly the same HTML code. The only difference is that each site uses a separate cascading style sheet, or CSS. Connecting to the internet. What is the point of designing a website if it cannot be seen? Viewing the web is relatively simple, but being seen is a little more complex. In this section, we'll consider how this connection is made so that everybody in the world can see your site using a typical setup. A modem provides the interface to the internet. Some functions of a box similar to this was explained in a previous video about networking. Point the browser at your box by entering its IP address. This is usually the address of the default gateway. Enter the username and password, and then click on the Advanced Setting button. Here you will see all of the settings that control the behavior of your modem. Click on the Firewall option and stop the firewall if it's running, and the Apply button if you've changed it. Otherwise, just click the Security button. Then select Port Forwarding. Your cable modem has an IP address used to connect to the big wide world, its WAN, or Wide Area Network address. IP addresses are scarce and require a lot of setting up, so a simple solution is to use DHCP. This allows your modem to make up its own IP addresses for use locally on your local area network, or LAN. These addresses have pre-selected reserved ranges that may be familiar to you, but the important point is that they are only for use on your LAN. That is why we can all use 192.168.0.1 without a problem. The modem then translates your local LAN IP address to your WAN IP. Select HTTP TCP/80 from the pull-down. Then enter the final number of your own Pi into this box here and press Apply. Ensure that this Enable box has a tick in it. Return to the home page and click on the Device Connection status. Your WAN address will be given at the base of this page. This is the address to tell your friends, so they can see the web page of your Pi. 2 points. We did say that IP addresses were in short supply. For this reason, you may discover that your WAN address changes slightly over time. Secondly, restore your firewall if you have concerns about it. This will be covered in a later video. The horrible truth. Now that your website can be seen by the whole world, you can prove your HTML skills by testing your code at the markup validation service run by W3C at this address. This is a valuable service, but sometimes the cause of some real frustration as you fine-tune your code to conform fully to the standards. The jingle on its failed, it's gone red. This has been a quick but comprehensive look at HTML on your Pi, and whether you've been restricted to just using a single device, two devices, or a combination of Pi and Windows machines, you should by now be fully versed in setting up an Apache server, using Nano to edit the text of HTML files, and view the output on a browser. Whatever the configuration, you should have a good basic working system and the ability to test your HTML skills. It's important that you solve any outstanding problems, as the same loop is going to be used to test other technologies such as PHP, MySQL, JavaScript, and cascading style sheets. HTML is at the centre of these technologies, as we will see in forthcoming videos. An understanding of HTML is therefore key to understanding and using all of these technologies. We have flown through HTML in this video, highlighting a few of the more important features, but a more complete introduction is available if you follow and download the pages referenced throughout each section. A lot more experience can be gained by following and, yes, copying some of the pages presented. Even more material will be added as time allows. One of the strengths of HTML is its ability to deal with new technologies. Early users would have been amazed at the way in which HTML has adapted to include full, feature-rich multimedia experiences, but these developments came at a cost. Given Sir Tim Berners-Lee's original generosity in proclaiming that this is for everyone, providing everything for free, it's a pity that some of the commercial organisations that followed in the development tried to dominate and capture the technology for their own. Search for Halloween documentation for some embarrassing revelations. The title, Browser Wars, was given to a period where browser writers introduced new features in their offerings to attract users to their platforms. This led to a total mess in code, misunderstandings, arguments, and a legacy that even today causes unnecessary confusion and complications. There are even a couple of obsolete items of code referenced in this video. The general agreement now is to work towards HTML5 and CSS3, and this should guide the longer-term design decisions you make. In the interim, watch these groups. As a final request, please type all unitary tags in this format.